All right, let's talk about a new language, but this isn't just going to be about syntax or features. Today, we are unpacking Merg-E, and what makes it so fascinating is that it's not trying to be a jack of all trades. Instead, it has this really strong, opinionated philosophy driving its design.
Merg is a highly opinionated language. Now, when you hear opinionated in the context of a programming language, I get it. You might think that's a bad thing, right? A limitation. But for Merg, it's actually the entire point. It's a deliberate choice born from a need to solve some very specific problems and to solve them incredibly well.
So what is that specific problem space? Well, Merg-E is what's known as a domain-specific language, or DSL. That just means it's not a general-purpose language like Python or C++. It is laser-focused on one particular job, building automated tools and infrastructure for Web 3.0. Things like bots, backends, and Layer 2 nodes.
So here's how we're going to break this down. Think of it like peeling an onion. We'll start with its core philosophy, then see how that completely shapes its approach to data. We'll do a deep dive into its most important data structure, and then get into a really surprising fact about its functions. And finally, look at the one very clever exception to that rule.
First up, an opinionated language. The whole idea here is minimalism and safety by design. Merg-E is built on the belief that the safest, most robust way to do something should also be the easiest way. It kind of nudges you toward writing better, safer code just by its very nature.
So, what does that philosophy actually look like in practice? Well, the first big consequence you'll notice is a radical, and I mean radical, simplification of how the language handles data.
Just look at the difference here. On the left, you've got a typical language with a whole toolbox of data structures, lists, dictionaries, sets, you name it. On the right, that's Merg-E. It has just two main ones, DAGs for structure and Dataframes for collections of data. That's it. It's a huge reduction in complexity.
So these are the two pillars of data in Merg-E. You've got the directed acyclic graph, or DAG, which is mainly for structure and managing authority, and then you have the data frame, which is the absolute workhorse for handling collections of data and processing them. And we're really going to zero in on the data frame because it's the key to how Merg-E solves one of its biggest challenges.
The data frame deep dive. See, a data frame in Merg-E is so much more than just a table of data. It's actually the secret weapon for achieving safe, high-speed parallelism and handling asynchronous operations, which, in the world of Web 3.0, are absolutely critical.
And there's this fantastic analogy that just nails the core concept. A data frame is like a house you can't start living in until it's ready. This really points to its unique, two-stage life cycle, which is what gives it all its power.
So what does building that house look like? Well, first you define the structure, right? You create an empty data frame and name your columns. Then you start adding your data, one row at a time. But here's the crucial step. When you're done, you freeze it. The entire thing becomes immutable, unchangeable. And only after it's frozen is it ready for processing. This whole process is exactly what makes it so incredibly safe to process in parallel, with no risk of conflicts.
Okay, so we've covered data structures. Now let's move on to another unconventional design choice, functions without returns. This flows directly from the language's commitment to something called zero-assumption parallelism.
Get this. In Merg-E, scheduled functions have no return values. Yeah, you heard that right. The standard function doesn't give you a result back. Now, why on earth would they do that? It's because of that zero-assumption parallelism idea. The runtime assumes any function could be run in parallel asynchronously, and traditional return values just make that whole model way more complicated and a lot less safe.
Which, of course, brings up the most obvious question in the world. If functions don't return anything, how do you actually get a result from a calculation? What do you do when you just need to add two numbers and get the answer? And that brings us to the inline exception. But don't think of this as some messy workaround. It's more like a finely crafted surgical tool designed for one very specific job: pure computation.
So inline isn't a special type of function. It's a pattern, a signal to the runtime about how to handle a function. It basically says, hey, run this thing immediately, don't schedule it. And to get the result, the runtime does something really clever. It secretly passes in an extra argument, a kind of callback, that your function then uses to deliver its final value.
But this power comes with some very, very strict rules. An inline function has to be pure compute, no side effects whatsoever. It can't capture outside variables and has to be immutable. It can't have any async operations, and it can't call any other functions that aren't also inline.
The point of all these limitations is to guarantee that inline is only ever used for safe, synchronous calculations, which keeps the entire safety model of the language intact.
Okay, so let's wrap this all up. We've seen that Merg-E is a highly opinionated DSL that is all about minimalism and safety. This core idea leads it to strip down data structures to just two: DAGs and data frames. Its data frames have that unique define add freeze lifecycle, which is perfect for parallelism. To make that parallelism safe by default, its standard functions don't have return values. And finally, the inline pattern gives you a tightly controlled escape hatch for getting results from simple, pure computations.
And all of this leads to a much bigger question about language design in general. By radically simplifying, by forcing a certain way of thinking, can a language actually become more powerful and more robust for the specific job it's meant to do? Merg-E is making a fascinating bet that the answer to that question is a definite yes.